All right, hey everybody, this is Dr. Flight. Hope you are doing fantastic today. We're going to spend just a couple minutes and talk a little bit about a MANOVA with two independent variables. So these would be two factor variables. So this would be like we have two non-metric grouping variables, and then combined together we have a variate which would have a series of dependent variables which would be metric that are being where weights are being estimated to help us design this problem. So as you set this up in this particular case, as I mentioned, we have two or more independent factors. And in this particular example, we have two. We have customer type and we have distribution system. Again, this is using the HBAT data. So if you want to, HBAT 200 data. So if you want to follow along and just run an analysis, then you can do this. So within SPSS and the multivariate method here, we can ask for descriptive statistics. So in this case, we have three dependent variables: satisfaction, likelihood to recommend, and likelihood to purchase. Satisfaction, likelihood to recommend, and then likelihood to purchase. And we have means available for each of these three variables, based, however, on customer type and then distribution system. So if we have three different customer types and we have two different distribution systems, 3 times 2 will equal 6, meaning that we'll have 6 different groups. So we have less than a year by customers who bought through a broker, and then we also have customers who've been with us less than a year who bought directly from us. And then we have the same two distribution system customers for those who have been with us from 1 to 5 years, and then also for those who have been with us for more than 5 years. So we have 3 levels of customer type and 2 levels of distribution system. So the 3 times 2 equals 6, meaning we've got 6 different groups. And then we have 3 different dependent variables. So, we have 3 times 6, we have 18 different means totally reported here, or reported here in all. And that's kind of where we go. That's how we move forward with this. So the question then is, is there significant difference between each of these 6 or any of these 6 groups and these 3 grouping, or these 3 metric variables, by using these 3 metric variables across them? And we're going to have it's really interesting how we do this, because you could have a interaction effect between these 2 variables, x1 and x5, but you could find, for instance, that customers vary. Customer type varies across these 3, like the groups of customers vary across these 3 dependent variables. You may find that they also vary across the 3 by distribution system. Or maybe not. I mean, we don't know, but we're going to have 2 levels, or two factors that are going on here in the independent variable, which is very different. And again, you couldn't do this with an ANOVA because you can't pick up the shared errors that are going on and any interactions that are going on here across the board. So like with all our analysis, you do the assumptions tests. So this is like a broken record where we do tests for heteroscedasticity. Again, what we're looking for are, the Levine's test, and specifically the box test under options and homogeneity tests, and everything here looks like it's above 0.05. So above 0.05 for heteroskedasticity in the Levine's test and M's test, and Box's M's test is sufficient. It's what you want to see. So that looks good. Again, like we've mentioned several times before, we have we can test for linearity with a scatter box plot. And when we do scatter box plots, we're looking for scatterings that are not in a circle, but rather straight like that, or something like that, where you can draw a line between the two variables here, which would be pairs of our dependent variables. We do correlation. Again, we can look for R. Can't draw an R particularly well, but R. So our correlation matrix could help us look for things that are below a 0.8 but above a 0.2 or so, and we're good there. Or we can do a Bartlett's test too. That might be sufficient. Tests for normality. So Shapiro-Wilk. I don't know that we're going to find a lot that's significantly that's normally distributed, but we can test for that. And then the Mahalanobis distance, or some other distance that we want to use. Going through here like we've done with the other tests or the other MANOVAs that we've run, just a regular straight up MANOVA, then a K-factor MANOVA, and now we have a two independent variable MANOVA. We're going to do the multivariate tests. And remember, there are two of these that we would normally run, but here we have the multivariate tests, which the Pillai, Wilk, Hotelling, and Roy is what we would look for each of the variables, and then an interaction. So, or for each of the grouping variables, so each of the factors, independent variables, and then an interaction for them. So that's what we want to look for there. That'll be unique and unlike the other tests that we have. So we have an interaction term that's going on. So this would suggest that, broadly speaking, without doing any post hoc tests, that this data differentiates one group from the other. And again, we kind of go back and we look at the means. And earlier when we looked at the descriptive statistics, you look at the means and it's kind of like a bunch of them. Remember I said there'd be 18 different means, and so eyeballing whether you see differences between them across each of the dependent variables like satisfaction and such, that can be kind of labor intensive. That can be a bit of a challenge. So that would be kind of a concern, if you would, moving forward. Now the univariate tests that we would run could be helpful as well. So remember, this is the multivariate tests that we run in MANOVA, and we again look at these four levels, four types of tests that are done and typically reported across each of the grouping variables, and then with this interaction that's going on here. So finally, though, kind of this interaction here, we have one that's bordering non-significance, but all of them are kind of on an individual basis. The univariate test between subjects, which again we've looked at before, meets our standards that we would accept. Okay, so this kind of wraps up where we are right here.